Hello everyone. Today's topic of discussion is frontier molecular orbital analysis of sigma tropic rearrangement. In the previous session, we have discussed about the introduction to frontier molecular orbital theory and the types of migration, suprafacial migration and anterofacial migration. Today I am going to discuss about the 1,3 hydrogen shift, the analysis of 1,3 hydrogen shift, whether that is taking place under thermal condition or photochemical condition. Now, in the previous discussion we have seen the sigma bond that is undergo homolytic cleavage, and there will be formation of allyl free radical as well as a hydrogen radical. For the analysis purpose we have to consider ground state HOMO. So, here ground state HOMO, that is Psi2. So, this is a non-bonding molecular orbital, and so the symmetry properties, that is in out of phase type of molecular orbital. The hydrogen atom, so that is we have to see the bond formation between the hydrogen atom and the carbon atom. So, whether that is forming on the same side of the system or opposite side of the pi system, and here this is overlap. If you migrate the hydrogen atom in suprafacial manner, so this interaction, that is a bonding interaction, because of positive and positive, that is a bonding interaction, but the other side, that is a plus minus, this is anti-bonding interaction. Although this is geometrically that is feasible, but symmetry that is forbidden, because of plus minus interaction, so that is a symmetry forbidden, that is anti-bonding interaction, there is no formation of bond. So, this reaction, that is not taking place. So, therefore, we can conclude that the suprafacial migration, so that is thermally forbidden, although that is geometrically feasible, but that is symmetry forbidden. The next let us see about the anterofacial migration of a hydrogen shift. And the anterofacial migration, so that is migration of hydrogen atom on the opposite side of the pi system. So, here the interaction, if you see the interaction between hydrogen atom and carbon, so this is a plus plus, that is a symmetry allowed, and here this is also plus plus, that is a symmetry allowed, but this is geometrically that is forbidden, because that is not favorable, that is because the distance between p orbital and s orbital, that is more. So, there is no effective interaction between s orbital and p orbital. So, therefore, there is no formation of bond. Therefore, although this is a symmetry allowed, but geometrically that is not favorable. So, the reaction that is not taking place. So, 1,3 hydrogen shift, that is thermally forbidden, either that is in suprafacial or anterofacial, both that is thermally forbidden. Let us consider photo-induced sigma-tropic rearrangement in the 1,3 hydrogen shift, whether that is feasible or not. For photo-induced sigma-tropic rearrangement, we have to consider excited state HOMO. So, already we have seen Psi3, that is excited state HOMO. So, here Psi3, that is anti-bonding molecular orbital. Now, we have to see the suprafacial as well as anterofacial migration, whether that is feasible or not. So, this is a suprafacial migration of a carbon atom. See the formation, that is a plus plus, that is a bonding interaction, and here this is also bonding interaction. So, therefore, this is feasible, because the symmetry that is allowed as well as that is geometrically feasible, that is the distance between s orbital and p orbital, that is less. So, therefore, this is geometrically feasible. So, therefore, photo-induced 1,3 hydrogen shift, that is taking place and that is thermally forbidden. So, we can conclude that 1,3 hydrogen shift, that is a photochemical reaction and that is thermally forbidden. Next, let us consider 1,5 sigma-tropic rearrangement. In this very similar explanation, so that is applicable to this rearrangement. So, here also we have to consider 2,4 pentadienyl radical, 2,4 pentadienyl system. So, that contains 5 molecular orbitals, Psi1, Psi2, Psi3, Psi4 and Psi5, and so there are 5 electrons. So, here HOMO, ground state HOMO, that is Psi3, and ground state LUMO, that is Psi4, and excited state HOMO, that is Psi4. For thermal reaction we have to consider Psi3, and for photochemical reaction we have to consider Psi4. Now let us consider suprafacial migration under thermal condition. So here for thermal reaction we have to consider ground state home. So this is ground state home, and the migration. So you have to see the transition state of hydrogen, migration of a hydrogen atom. So positive, positive and positive. So in both sides that is a bonding interaction. So therefore this is a symmetry allowed, and geometrically that is also feasible. So therefore 1,5 hydrogen shift is symmetry allowed and geometrically feasible, and that is taking place, or that is thermal reaction. Now let us see the antifacial migration for the same. Here that is a let us consider photo-induced reaction. So that is a photochemical HOMO, Psi4, that is a photochemical HOMO. Here the interaction, so the interaction that is antifacial way, that is the opposite side of the pi system, that is plus plus and plus plus. Here this is also that is a symmetry allowed, but that is geometrically not feasible, because the distance between s orbital and p orbital that is more. So therefore this is geometrically feasible. So antifacial migration that is not taking place in 1,5 hydrogen shift. So we can conclude that 1,5 sigma tropic shift is thermally allowed and photochemically forbidden. So this is about the analysis of frontier molecular orbital theory. So the conclusion is, on the basis of frontier molecular orbital theory, one can analyze whether the reaction that is taking place under thermal or photochemical condition, and we have analyzed the 1,3 hydrogen shift, that is photochemical reaction, and 1,5 hydrogen shift, that is a thermal reaction. Thank you.